Alrighty, so you may just see problems on the screen. I started doing this video and I tried to use my theory, and sometimes having pre-written notes makes for a really bad lecture. I got like halfway through the lecture and I just decided to punt and do the lecture without my notes because the concepts are pretty easy. They hardly need notes. The first problems, at least the first four problems, are just multiplying decimals. Super easy to multiply decimals. If you can multiply 2 and 3 digit numbers, multiplying decimals is not particularly hard. In problem 2, I want to multiply 4.2 times 5.7, and usually when you multiply decimals, your answer is going to be a decimal. If I know how to multiply 42 and 57 without the decimal, it's not particularly hard to multiply the 42, the 4.2, and 5.7. I'm just going to multiply problem 2 just like I would multiply 42 and 57. In fact, I'm going to ignore the decimals and make a little note to myself. Because there are two numbers behind the decimal, one from the 4.2, one from the 5.7, my answer needs 2 numbers after the decimal. So I'm going to multiply without the decimal. Just generic multiplication that I'm actually not that great at finding. But I'm going to start. Let me do this multiplication. I'm going to go 7 times 2 is 14. 7 times 4 is 28. Add the 1 and get 29. Done with the first level. Now 5 times 2 is 10. Write the 0 down. 5 times 4 is 20. Carry the 1 from the 10. 20 plus 1 is 21. You'll notice on the second line, I started it one slot over, one position over. Now I'm just going to add down. I'm going to go 4, bring it down. 9 plus 0 is 9. 2 plus 1 is 3. Bring down the 2. There's a decimal that's implied after the 4, and I need to get that decimal. So there's 2 numbers after the decimal, so I'm going to drag that implied decimal 2 to the left. And for an answer for problem 2, I'll say 4.2 times 5.7 is equal to 23.94. When I do problem 4, I'm actually going to multiply 314 times 23. I'm going to multiply the numbers without the decimals. It just makes my life easier, and I'm going to do some legwork at the front here before I do the multiplication about my answer. Here in number 4, I'm multiplying a positive times a negative. My answer needs to be negative. And that's part of the issue. The other part is the number of digits behind the decimal place in my answer, and in 3.14 there's 2 numbers after the decimal. In 2.3 there's 1 number after the decimal. There's a total of 3 numbers after the decimals. My answer needs, it has to be negative, and my answer needs 3 numbers after the decimal. I haven't written tests yet for this semester. I'm probably leaning towards not putting multiplication with decimals of this fashion on the test. It doesn't come up a lot in our course, and I'm comfortable letting you use calculators for decimal multiplication. But just to get practice here, let's do this. So first, I'm going to go 3 times 4 is 12. Carry the 1. 3 times 1 is 3. Add the 1 and get 4, and then 3 times 3 is 9. Move over to the 2, do the multiplication, and bounce it 1 over. I'm going to go 2 times 4 is 8. 2 times 1 is 2. And 2 times 3 is 6. I'm going to bring down the 2. I'm going to add the rest of the way. 4 plus 8 is 12. I'm going to bring the 1 up. 9 plus 2 is 11, plus the 1 that I carried over is going to give me a 12. Bring the 1 over. That's left over from the 12, and 1 plus 6 is 7. When I go to write my answer, I've got two issues. I need to get the decimal so that there's 3 numbers after the decimal. I'll take the implied decimal, drag it 3 over to the left. So in my answer, the decimal is going to be between the 7 and the first 2. And because I multiplied a positive times a negative, my answer needs to be negative. So in problem 4, my answer should be negative 7.222. I kind of feel like I really shorted you on practice problems in this section, but it is what it is. If you want some more problems, let me know. I can write these up all day. They're easy to make up. And I noticed that I forgot the time sign in problem 6 to make it look like 5, 6, 7, and 8. So let me just sneak it in there, and I'll fix this when I get done with the video. The next 4 problems on this sheet are decimal multiplication, but they're multiplying by powers of 10. And multiplying by a power of 10 can be accomplished by moving the decimal. If you multiply by a positive power of 10, to do the multiplication, you just move the decimal that many places to the right. And all 4 of these are that kind of problem. Turns out that if I multiply by a power of 10 that has a negative exponent, for those of you taking chemistry, you get a lot of negative exponents, you'd move the decimal to the left. Anyways, this, I'm just going to drag the decimal 4 places to the right, because anytime I'm multiplying by a power of 10 that it has a positive integer, I just move the decimal that many places to do the multiplication. So the decimal now goes between the 8 and the 7. And when numbers get big, I like to have commas. Usually to decide where to put the comma, I start at the decimal place and go, each time I go 3 to the left, I insert a comma. So I'd probably put a comma there. You could read this as 42,358.7 or 42,358 and 7/10. 8's the same style of problem. It's multiplying by a power of 10. The power is a positive 3. To do the multiplication, I probably should have equal signs here, but I don't. It's not the end of the world. To do the multiplication, I need to move the decimal 3 places to the right. Well, in problem 6, when I moved the decimal 4 places to the right, I didn't run out of numbers, so I got an easy answer. In problem 8, after I moved the decimal just 1 place, I'm already out of numbers. So I continued and I made little valleys, and in those valleys I'm going to plug zeros. So if I go beyond my numbers as I'm multiplying by a power of 10, I need to fill in zeros. So my answer would be 5,100 decimal point. That's where the decimal would go. But I don't need to write that decimal. That's implied. It's not necessary. And the comma, I'd start at the decimal and go 3 to the left for an answer to problem 8. I think 5,100 feels good for that. All right, so first skill, just multiplying with decimals. Second skill, dividing with decimals. Dividing with decimals, it's tedious to say the least. Long division is not one of my favorite things to do. This is long division, and the decimals don't make it an issue. So in order to do division with decimal, we need to write this as a long division problem. The divisor, which is after the division sign, is going to go outside the division bar. And then I'm going to get my division bar. And then the dividend, the number before the division bar, goes under the division bar. So this is the division I need to do. And I can't get rid of the decimals like I did with multiplication. I can't get rid of them, all the decimals, but I can get rid of one of them. The decimal that is outside the division bar, or the divisor, I should get rid of it by moving it so it's beyond, so there's no decimal. So I need to move this decimal point 1 over to get rid of the decimal. I'll do a corresponding move under my division bar. So I'm going to rewrite this problem as 21 divided into 172.2. If you're rusty on your long division, so am I. I'm not inclined to put a long division problem like this on the test. It doesn't come up a lot in our class, and if we get ugly decimals, I'll let you use your calculator. Be nice to, do this right now, but if this isn't, if you're not feeling super comfortable with this, it's not going to drag you down for the rest of the class. So first I ask myself, does 21 go into 1? No. Does it go? It's too big to go into 1. It's too big to go into 17. How many times does 21 go into 172? Well, I could do it on my calculator to figure out what number goes up top, but it's a little bit complicated. If I do 172 divided by 21, my calculator gives me a fraction. I hit the SD number. I'm going to put an 8 on top of my division bar, right over the 2 because I'm getting rid of the 172. And now I'm going to multiply 8 times 21. I'm going to go 8 times 1 is 8. 8 times 2 is 16. When we do long division, we subtract. Let me bring this decimal up because I'm going to need it. To do this subtraction, the 7, I'm going to borrow 1 and make it a 6. I'm going to change the 2 to a 12. I'll do 12 minus 8 is 4. And then 6 minus 6 is 0. 1 minus 1 is 0. I don't need to do anything else. I don't really need to worry with the decimal. I have it up top where it needs to be. I'm just going to bring the 2 down without the decimal. And I'll ask myself, how many times does 42 or 21 go into 42 by going 42 divided by 21? That means I'm going to put a 2 on top of my division bar. It's nice if I don't get a decimal here, there's no remainder. Now I'm going to go 2 times 1 is 2. 2 times 2 is 4. And subtract, I get a remainder of 0. Done with this decimal division. The answer to problem 10 is 8.2. Lots of issues going on with number 12. I'm not going to worry about the sign. That's just going to mess me up. I'll just make a note to myself that my answer has to be negative because I'm dividing a positive divided by a negative. So I'm going to put the divisor to the left of the division bar, the dividend to the right of the division bar, and get rid of one of the decimals. The decimal outside the division bar I can get rid of by just moving it 1 to the right. I need to correspondingly move the decimal under the division bar. So now I need to do 31 into 133.3. And 31 doesn't go into 1, 31 doesn't go into 13, 31 does go into 133. And how many times? I go 133 divided by 31. This calculator makes everything in the fractions, which turns out to be good. I'm going to SD it, and it's disgusting, but I just need the number 4. So I'm going to put a 4 on top of my division bar. And now I'm going to multiply the 4 on top of the division bar by the 31 out front. So I'm going to go 4 times 1 is 4. 4 times 3 is 12. And I'm going to subtract. From this 3, I'm going to borrow 1 and make it a 2. I'm going to make the 3 there into a 13. I'm going to go 13 minus 4 is 9. These 2's cancel, those 1's cancel. I'm going to bring down the 3. To figure out what goes after the decimal, because I just brought the decimal up, I'll take the 93 that's left under the division bar, divide it by the 31 outside the division bar. That tells me I need a 3 up top. Again, I'm not inclined to put these on a test, so kind of relying on my calculator a little bit. I could do it in my head, but I don't know that you can follow me doing math in my head. So this is what I'm thinking. How many times does 31 go into 93? Or I can figure that out just by doing that division. And now up top I go 3 times 1 is 3. 3 times 3 is 9. I subtract and get a lovely remainder of 0. These things could get way worse. I could have answers that have repeating decimals or terminating decimals that go further on than we have here. I almost messed up because I told myself my answer is negative. I didn't write that negative in my answer, so let me sneak it in there. super easy to mess that up when you're working by hand. All right, so that's the next skill. So the first two skills, multiplying decimals, dividing decimals, not likely to show up on our test over the chapter. The next skills will probably show up, and they're important skills. A little bit in our class in general, they're important. And I've got another issue here. Problem 14 should say convert 24.155% to a decimal. It's real easy to take a percent to make it a decimal. To make a percent into a decimal, you just need to move the decimal, and you just move it 2 to the left. So to convert any percent to a decimal, it's almost no algebra. It's like multiplying by a power of 10 easy. So to convert a percent to a decimal, move the decimal 2 to the left and stop writing the percent sign. So in problem 14, there's a decimal in between the 4 and the 1. I'm going to move it 2 to the left. It's going to precede the 2. So when I go to write my answer, I can just say the decimal version of 24.155% is 0.24155. This is a correct answer. The decimal's placed correctly, but usually if a decimal is the first thing I need to write, to make that decimal stand out, I put a 0 preceding the decimal. I'm pretty consistent about that. I think my calculator is as well. Next problem, a little bit messier. It's double steps. To convert a percent to a fraction, first you make the percent into a decimal, then the decimal into a fraction. Neither one's particularly hard, but the first is easier. So to do a percent to a fraction, first make the percent a decimal. And that's the skill that we just had up top. How do I make a percent a decimal? I drag it 2 to the left. So the decimal version of 12.3% is going to be 0.123. Second, I now need to create a fraction. This is real easy to do as well. Second, I'm going to create a fraction. It's easy to create the fraction, sometimes not that easy to reduce the fraction. I might go back and do 15 with you. How do I create a fraction? I take the number that's the decimal and I write it without the decimal. So I'm going to take the decimal and not write it in that number. And I'm going to create the fraction I'm asked to create. In the denominator of a fraction, it's going to start off with a 1 followed by as many zeros as I had to move the decimal to get rid of it. I needed to move the decimal 3 times to get rid of it, so I'm going to get 3 zeros in the denominator. I don't think this fraction reduces. I think I've successfully changed the fraction, the percent to a fraction, using the intermediate step of making a decimal. Let's do 15 together, which is a little bit harder because I think your fraction reduces. So if you want to pause the video and try 15, that would be better than just watching me. So first, for 15, in my efforts to change a percent to a decimal, to a fraction, first I make a decimal. So I'm going to move the decimal 2 to the left. The decimal version of 25.4% would be 0.254. And now I'm going to create a fraction. And I don't know why I was nice to me and mean to you, but I was. Your fraction's going to have the non-decimal version of the decimal, a horribly stated sentence, in the numerator. And in the denominator, a 1 followed by however many numbers were after the decimal place. There were 3 numbers after the decimal place. That's too big. That's not on my sheet of numbers to reduce. And now I'm going to have to do some clever reducing because this is a reducible fraction. Both the 254 is even and the 1000 is even. I'm going to reduce by dividing both by 2 and do 254 divided by 2 and get 127. And I'm going to do 1000 divided by 2 and get 500. I don't think that reduces anymore. I would never give you something this big on the test to worry about. Let me just break out my calculator. It doesn't obviously reduce to me, and my calculator tells me that in fact it doesn't reduce. So the answer to 15 is that. So 17 and 18, I probably should have had before 15 and 16. It was poor planning on my part. 17 and 18 give me a decimal. They want me to make it into a fraction. Totally can do this because I just did it twice. If you're given a decimal and you want to make it a fraction, you write the number without the decimal. In this case, 24. I'm not going to worry about the 0. I'm going to put a power of 10 in the denominator. It's going to be a 1 followed by as many numbers were after the decimal. And in the problem 18, there were 2 numbers after the decimal. So the fraction version of 0.24 is 24 over 100. And that's even too big for my sheet of reduction, I think. I don't know that I have 100 on there. No. Yeah, I do have 100 on there. So I probably could reduce this with my sheet. 100, if you can't obviously reduce this, 100 is 1 times 100. It's 2 times 50. It's 4 times 25. It's 5 times 20. And 10 times 10. And the 24 is up here. It's 1 times 24, 2 times 12, 3 times 8, and 4 times 6. If I look through and try to find the biggest number that these two lists have in common, I think it's the 4. So to reduce this fraction, I can say 24 is 6 times 4. I could say 100 is 25 times 4. And now I can hack out the 4's. And the reduced fraction version of 18 is 6 over 25. Give 17 a go. Maybe pause the video and I'll do it with you. It's not particularly hard, but it's probably good just to do right now when it's fresh. So for 17, I'm going to make a fraction that has the non-decimal version of the number in the numerator. In the denominator, it's going to be the power of 10, a 1 followed by 2 zeros. I have the factors of 100. The factors of 12, if I wanted to reduce these, the factors of 12 are 1 and 12, 2 and 6, 3 and 4. And if I compare them to the factors of 100, the common factor that I need to worry about is this 4 and 25 again. I can reduce by 4. So if I wanted to, I could say 12 is 3 times 4. 100 is 25 times 4. And I can reduce, and get 3 over 25. We're at 25 minutes. Let me see if we're at a stopping point or if I should go just a little bit further. I can tell this crud here because I'm not using my lecture notes. Let me pause and do a part 2, just so we're at 25 minutes and make the second part kind of equally long.